Hello students, in this video we'll discuss how to use convolution together with the Laplace transform. Given two functions, f of t and g of t, their convolution which we write as f star g is, and so here's the formula for convolution. F star g of t is the integral from 0 to t f of u g of t minus u du. And one property of convolution that's important is that it's commutative. It doesn't matter if I do f star g or g star f, they give me exactly the same thing. This will also be equal to the integral from 0 to t of g of u f of t minus u du. So the order of convolution doesn't matter. We can do it in either order. Now the fundamental property of convolution Laplace transform is the following. So f star g, the convolution of f of g, Laplace transformed at t in the new variable s will be f tilde of s times g tilde of s. So the Laplace transform of the convolution is the product of Laplace transforms. Laplace of convolution is product of Laplace transforms. So this is the formula we'll use principally when we're solving these problems. So let's see an example of this. Let's find the Laplace transform of the integral from 0 to t of u squared sine of t minus u du. Well, we notice that the expression that I'm trying to Laplace transform is the convolution of the function t squared, that's my u squared, and sine of t. Now I can use the fact that the Laplace transform of the convolution is the product of Laplace transforms. And so we'll see that the Laplace transform of t is 1 over s squared, and the Laplace transform of sine is 1 over s squared plus 1. So the Laplace transform of this integral is exactly 1 over s squared times 1 over s squared plus 1. Now we can use the reasoning in reverse order. So let's look at this example. Let's find the inverse Laplace transform of 1 over s minus 1 times s minus 3. Now we could use partial fractions and then invert the individual terms in the Laplace transform, or we can use convolutions. By the convolution theorem, this will be the inverse Laplace transform of 1 over s minus 1 convolution the inverse Laplace transform of 1 over s minus 3. Now we know each of these individual Laplace transforms. This is e to the t, convolution e to the 3t. Now we will find e to the t convolution e to the 3t by the integral formula. E to the t convolution e to the 3t is the integral from 0 to t e to the u, and then e to the 3 t minus u du. Now this e to the 3t in my integral can be factored out since it doesn't depend on u, and we'll be left with e to the 3t, the integral from 0 to t. I have an e to the u and an e to the negative 3u. That's an e to the negative 2u du. And now we will integrate this. This will be e to the 3t. And then I'll have an e to the negative 2u over negative 2, evaluated from 0 to t. Now when I plug in t, I'm going to have e to the 3t times the quantity e to the negative 2t over negative 2. And then I'll have a minus the bottom, which will turn into a plus 1/2. So if I simplify this, I will have a negative 1/2 e to the 3t times e to the negative 2t is going to be an e to the t. And I'll have a plus 1/2 e to the 3t, and that is our inverse transform. Thank you very much.